Good afternoon. This is Mrs. Jacobs. I will be showing you today grade 4 Go Math lessons 5.1 and 5.2. Teaching point: I can find the factors or factor pairs of a number. And this is standard 4.OA.4. A factor is a number multiplied by another number to find a product. Every whole number greater than 1 has at least two factors: that number and 1. So, for example, 18, the two numbers that multiply to equal 18 is 1 times 18. And that's for every number. Every number has two factors, 1 and itself. Even though there are other factors for 18, I could do 2 times 9. That also equals 18. So 2 and 9 are also factors of 18. Two factors that make a product are sometimes called a factor pair. So when we're finding factors of numbers or factor pairs, the number will usually not go past 100. So meaning that we would have to find all the factors of 100 and then all the factors of 0 or 1. So the number shouldn't get larger than 100. So how do we find all the factors of a number? The factors of a number are all those numbers that can divide evenly into the number with no remainder. The greatest factor of a number is the number itself. So you can always list all the factors of any number because you have a stopping point. So let's go back and use that number 18. So if I was to ask to find all the factors of the number 18, okay, I know that 1 and 18 are definitely factors. And that's what it means. The number itself is always going to be a factor. So 1 times 18, those are two factors, 1 and 18. Now I think to myself, what other two numbers do I multiply that also give me 18? And then I start to think about it in a sort of a pattern. So I think about 1 times 18, and then I say to myself, I'm going to try the 2 times tables so that I don't leave any factor out. So after 1, I'm always going to try 2, right? So 2 times what will give me 18? Well, I know that 18 is divisible by 2 because it's an even number. And all even numbers are divisible by 2. So I think to myself, 2 times what will give me 18? And I know that is 2 times 9. Okay. Then after I tried number 1, I tried number 2, I keep going on in this counting numbers. So the next number that is up is 3. So I ask myself, is 18 divisible by 3? What does that mean? Does 3 go into 18 evenly with no remainder? So think about your 3 times tables, okay? So I know that 3 times 6 is 18. So now I try 4. And I'm thinking about my 4 times tables, and 18 is really low, so I could do my multiples of 4, right? 4, 8, 12, 16, 20. No, I don't get 18. So 4 is not a factor of 18. Then I try 5. You know, you have to keep on going. And I'll tell you when to stop because it's important. So I tried 5, and I say to myself, can 5 go into 18 evenly? So that means that no remainder. But I know that when I do the multiples of 5, my number has to have a 0 or a 5 in the ones place, right? And I'm looking at 18, and there's an 8 in the ones place, so I know 5 is not a factor. But I also could just try it out and say 5, 10, 15, 20. And as you can see, we don't get 18. So 5 is not a factor. So then I go to 6. But if I look at my factors, 6 is already there. So once I have found a factor that's already there, I don't need to go any further. This means that you have found all the factors of 18. Okay, so remember, a number is divisible by another number if it divides evenly with no remainder. The remainder must be 0 in order to be a factor of a number. So let's look at an example. 2 is not a factor of 21 because 21 divided by 2 is 10 remainder 1. Also, 2 is divisible by even numbers only. And 21 is odd, so that's not going to work. All right, so we'll have to talk about and think about a few things when we're trying to find factors. But most importantly, when the numbers get large and we're not sure if a number is a factor of another, we have to do a little work, okay? And that's division work. And it's like a trial and error. We got to try numbers, and some will work and some won't. All right, so we're going to start off very basic, and we're going to list all the factors of 6. Now, like I said before, 1 and itself. So since we're working with 6, we know that 1 and 6 are definitely factors. How do I know that? Because I have 1 times 6. Okay. So again, like I said, we keep on going, and we already did 1 times 6, and now we're going to try 2. 2 times what will give me the product of 6? I know 2 times 3. Now I go ahead and I say, okay, I did number 1, I did number 2, and now I'm going to try number 3, but guess what? That's already there. 3 is already there. So at this point, I can stop and say, I have found all the factors of 6. Now, how do I represent them in an organized manner? So I look at these factors, or factor pairs, really, and I say, how can I list them? Well, this is what we do. We list the factors in order from least to greatest. So if you will notice, least to greatest, I'm going to do 1, 2, 3, 6. Okay? And if you know what I did is I actually started here, right here, and then I just like did this U shape, right? So I went from all the way down 1, 2, and then I went around to 3, 6. So when you are listing factors of a number, they always must be put in order from least to greatest. All right, so when listing all the factors of a number, we need to put all the factors in order from least to greatest. And we have a little way to remember that, and we call it the factor rainbow. And that allows us to put all the factors in order from least to greatest. So I'm going to show you how we use the factor rainbow. So it says find all the factors of 12. Again, 1 times 12. So what we're going to do is we're going to put the 1 here. That's the lowest factor, but 12 is the highest factor. So I'm going to put it all the way at the other end. Think of the other end of the rainbow. So I have 1 here, so 12 is going to go at the end. And I connect it like so. Then I go and I say, what's the next factor? Well, I'm going to try 2. 2 times what will give me 12? So I'm going to put a little comma here to separate the numbers in my list. So 2. 2 times what will give me 12? I don't put it right next to the 2. I start one number at one end, and now the other factor goes at the other end. So 2 times 6 is 12. So I have to put the comma and put the 6 over here. And then I connect it. Then I keep going on and I say, okay, let's try 3. 3 times what number will give me 12? So I know 3 times 4 will. So I'll do 3, 4. Okay. And then I will connect the 2 factors. And then after 3 comes 4. 4 is already there. I don't need to go any further. I don't need to try 5. Nope. Because once I hit a factor that is already here, I know that I have found all the factors of that number. So if you look, we created a rainbow that connects one factor to the other. Okay, I'm going to go place a comma in between 3 and 4 because we have no more numbers. Okay, so these are all the factors of 12. 1, 2, 3, 4, 6, and 12. So if I count them up, I have 1, 2, 3, 4, 5, 6. I have 6 factors. Right? But if I look at factor pairs, 1 and 12 makes 1 pair. 2 and 6 make a second pair. And 3 and 4 make a third pair. Okay. Okay, so instead of using a factor rainbow, which helps us to list all the factors of a number, in the video, the numbers will get a little bit higher, larger, for a reason, because the lower numbers are more easier to work with, and the larger numbers is just more time consuming and more work put into it. All right, so there is another way that we can find all the factor pairs of the product, and we're working with the product 21. So yes, we can use a rainbow. So I'm showing you different ways to organize the work. Okay, so we have a factor rainbow. Now we're going to try a factor table. Okay, And this table is going to organize all the factor pairs. So this is great for showing work for factor pairs. Okay. And first we start by creating a table, 2-column table. Okay. Trying to make it wide enough to give you some room inside of them. And I'm going to say factors of 21. Okay, and I'm going to start the same way as I did before. So I know 1 times 21. So I'm going to put 1 times 21. And then over here in the next, I'm just going to put 1 comma 21. So I have the multiplication fact in 1. And off in the second column, I actually list the 2 factors. Okay. Then I try the 2 times tables. Okay. And guess what? I have to think, does 2 go into 21? And I know we said earlier that it doesn't, but let's say I had no idea. So what I do off to the side is I actually see if 2 goes into 21 evenly with no remainder. So I actually divide to find out this answer. So 2 goes into 2 once. 1 times 2 is 2. Subtract, bring down, I get 1. Does 2 go into 1? No, it doesn't. It's 0 times. 0 times 2 is 0. Subtract. So this answer is 10 remainder 1. So no. Remember, to be a factor, you have to divide evenly. So I will not put 2 as a factor. So since 2 is not a factor, I skip that and I go to 3. Okay? And I'm going to try the 3 times tables. So I know that 3 times 7 is 21. So I write 3 and 7. Then I try the 4 times tables, and I'm going to skip count by 4 and see if I get to 21. So 4, 8, 12, 16, 20, 24. No, I never get the product of 21, so 4 is not a factor. So I keep on going, and I tried 4, now I'm going to try 5. Now I automatically know that 5 is not a factor of 21 because of that same thing we were thinking about before, is that in order to be divisible by 5, your number has to have a 0 or a 5 in the ones place. And 21 does not, but we can try it. Let's skip count by 5s and see if we ever get the product of 21. 5, 10, 15, 20, 25. Nope. No product of 21, so 5 is not a factor. Work is not done. We're going to keep on going. So we try 6. And we do the 6 times tables. And guys, we do this as practice, right? And also since our number 21 is really low, right? So that we could figure out with basic facts, right? So I'm going to do the 6 times tables. 6, 12, 18, 24. Nope, no product of 21, so 6 is not a factor. And then I go and say, oh, my next number is 7. But guess what? 7 is already there. So I know I have found all the factors of 21. So if I was asked to list all the factors, I would say 1, 3, 7, 21. Remember that when you're listing factors, they're in order from least to greatest. Okay. But if it says the factor pairs, the factor pairs of 21 are 1, and 21, comma, 3 and 7. Okay? And again, I can use the factor rainbow to connect my factors just to make sure. So I have 1 times 21, check. 3 times 7, check. And that's it. So in this case, it only had 4 factors. Okay? 4 factors, but 2 factor pairs. All right, so now we're going to find all the factor pairs for 95. Okay, so I'm going to show both. I'm going to show you using the table and as well as using the factor rainbow. So let's think. I'm looking for the factors of 95. The factors for 95. Okay, now 95 is a very large number. Okay, so it's beyond basic facts. So we will use basic facts to help us, but we need to do a little bit more with division. Okay, so let's think of the factors of 95. Again, 1 and itself. So 1 times 95. So that means the factor pair is 1 and 95. Okay, so I could put that in my rainbow, right? So I have 1 over here. And remember, when you're doing the factor rainbow, 1 factor is on one side of the rainbow, and the other factor is all the way at the other end. So the largest factor is the number itself, 95. So I should have no factor past 95. That's the end of the rainbow, okay? So now I start thinking, and again, I did 1, I say 2. Does 2 go into 95 evenly with no remainder? And because we've been really looking at patterns, we know that 2 does not go into 95 evenly because 95 is odd, right? And only even numbers are divisible by 2. So 2 is out of the question. So I move on to the number 3. Now I say to myself, I know 3 goes into 9, right? But 3 doesn't go into 5. But guess what? I'm not entirely sure. So when in doubt, divide. So I will take 95 and divide it by 3. Now remember, if we get a remainder, then 3 is not a factor. It has to go in perfectly evenly. So let's do the division. 3 goes into 9 3 times. 3 times 3 is 9. Subtract, bring down. 3 goes into 5 once. 1 times 3 is 3. Subtract, have no more to bring down. So it's 31 remainder 2. So 3 is not a factor. Okay, so I'm just going to go and erase that because this is going to be my show work area. Now I'm going to try 4. Okay, and I'm thinking it's not a factor. But guess what? We have to make sure because we do not want to skip a factor because this says all. Okay, so we're going to try 4. So let's see if 4 goes into 95 evenly. So how many times does 4 go into 9 without going over? That's twice, which is 8. How many 4s go into 15? That would be 3. Oh boy. We have 23 remainder 3. Nope. It doesn't go in evenly. You're not allowed to have a remainder, so it's not a factor. So 4 is not a factor of 95. All right, so the next number up is, I tried, we have 1, 2 doesn't work, 3 doesn't work, 4 doesn't work, but try 5. Now, I know that 5 works. I might not know how many times, but I definitely know 5 works because 95, right? So in that ones place, there's a 5. So I know that it is divisible by 5. All right, so I have to do the division work anyway because I have to find another factor. So I know it's 5 times something. I just don't know that yet, right? So I can go in my table and I know it's 5 times. I don't know that answer yet. I have to do the work and I will find that out. So we'll go off to the side and do 5 into 95. 5 goes into 9 once. 1 times 5 is 5. Subtract, bring down. How many 5s go into 45? That's 9. 9 times 5 is 45. Yay! Remainder is 0. No remainder. So this works out evenly. That's how we say it. So 5 times 19. See? And we would have known that because that's not a basic fact. So 5 and 19. All right, now we have to move on and try 6. Let's see if 6 works. 6 into 95. You have to have patience when we're doing questions like this. 6 into 35. 6, 12, 18, 24, 30, 36. Nope, 30. So 5 times. Oh boy. Nope, this is not going to work. So 6 doesn't work. Let's do 7. That's not going to work. Then we do 8. But now we're getting closer to basic facts, right? So 8 times 11 is 88. So I could think of that. And 8 times 11 is 88. And add another 8. Nope. That's 96. Nope. So it's not 95. So 8 doesn't work. Then I try 9. Oh boy. 9 times 10 is 90. 9 times 11 is 99. That doesn't work either. And then we get to 10. And at this point, 10 times 10 is 100. So we already know at this point that we have found all the factors of 95. That's it. So we have 1 and 95 and 5 and 19. Okay. And find all the factors of 95. We did the factor pairs. The pairs are 1 and 95, 5 and 19. Okay, so that makes 1, 2, 3, 4. We have 4 factors, but 2 factor pairs. Okay, so yes, it is time consuming, especially when we're working with larger products such as 95. Okay. All right, so next thing up is we have to tell whether a number is a factor of another number. Okay, and this is where your multiplication facts, right, come in. So let's take the first question. Is 4 a factor of 24? So basically this is asking, if I do 4 times another number, will it give me the product of 24? I could think of the multiples of 4 And when I do the multiples of 4, do I ever get 24? Okay. Or I also could sit here or stand here and list all the factors of 24. Not necessary to do that, since if I could figure out the factors that do equal 24, where a 4 is involved, right? So I think of the multiples of 4, and I say to myself, 4 times what will give me the product of 24? So I'm thinking 4, 8, 12, 16, 20, 24. And that is 4 times 6, right? So is 4 a factor of 24? Yes. Because 4 times 6 is 24. So I actually found the factor pair. The factor pair is 4 and 6. Sorry for that. All right, so next question up. Is 7 a factor of 50? So I'm going to think of the multiplication facts for 7, right? And I'm thinking, right, because factors are two numbers that when we multiply, they give us a product. So is there any number that I can multiply by 7 and it's going to give me 50? Well, if I do my 7 times tables, I know that 7 times 5 is 35, 7 times 6 is 42, and 7 times 7 is 49, and 7 times 8 is 56. So we didn't get a product of 50. So in this case, 7 is not a factor of 50. So we could say no, because, and I need mathematical evidence, right? So no, because 7 times 7 is 49, and 7 times 8 is 56. We can use our multiplication facts to help us prove, right, why it isn't. I also could say no, because 50 is not a multiple of 7. I could also say that. All right, so let's try the next one. Is 9 a factor of 99? Okay. So again, we're thinking of the 9 times tables. And 9 times 10 is 90. 9 times 11 is 99. Bingo. So 9 is a factor of 99. And we'll say yes. Oops, that was supposed to be an 8. Yes, because 9 times 11 is 99. And I also could say 99 is a multiple of 9. Right? All right, so now it's your turn. Okay, you're going to copy and answer in your math notebook. Copy the question and answer it. And please follow what strategy I'm asking you to do. Okay, so for the first one, find all the factors of 26 using a factor rainbow. All right, so make sure that you are trying to find all of them. Okay, can't miss any, so you're going to have to make sure you get to the point where you can't find any more. Okay, and the second question says find all the factor pairs of 64 using a table. So I want the factor table, and look at the question. It still says all, but I want factor pairs this time. Okay, and then the last question is checking to see if you could determine if a number is a factor of another number. So yours is 5 a factor of 56? How do you know? So can't just write yes or no. You have to give me mathematical evidence to support your answer. Okay? Remember, you could always rewind and play back the video again. Okay? And I will see you tomorrow in class to work more with factors. All right, so thank you for joining me, and I will see you tomorrow.